Alright, my name is Adam Perkins.
And I'm Michael Cadena.
And we're here to talk to you about 3D displays on a flat screen. To convey a 2D image on a flat screen to 3D in your eye, there's one problem that has to be solved. And that problem is you have to give one image to the right eye and one image to the left eye. And that's the problem that everybody that's trying to make a 3D video has to compete with. There's a bunch of ways to do this. One of the ways is polarizing glasses, and that's the kind of stuff you're going to see when you go to watch an IMAX or a RealD 3D or any of that stuff. And what they do is they take advantage of the fact that light is not polarized and that you can polarize it. So one eye is going to get the vertical waves coming in, and the horizontal ones are going to be blocked out, and the other eye is going to get the horizontal waves, and the vertical ones are going to be blocked out.
Alright, so here we have a 3D cube. It's a different way to show 3D motion. What it is, it's like 500 or so LEDs, and they are going to go off in a sequence, and as that sequence goes off, it creates an image of where it's almost like a wave moving through it. And we have a video that demonstrates this.
Alright, not 3D glasses, and that wave pattern there is kind of what this guy really built this thing for. What he did was he took this cube matrix and he did some vector calculus, and he specified all those x, y, and z coordinates for each light, and he took a sine wave and put it into 3D. Now this kind of violates the 2D surface with a 3D image, but the concept is really good because he took a whole bunch of layered pixels, and if you crunch those together, you could get those down to a semi-flat viewing screen. And then what you can do is you can light up the ones in the back versus the ones in the front, and you can actually get that depth perception created by the 3D effect on a 2D screen. So this was a really good example, and again, he used actually MATLAB to program all these little vector points to get that sine wave going on the cube here. And then next, let's see. Come back to our presentation. And next we have the 3D video with the 3D glasses. And before we watch that, I want to show you one slide and kind of break things down. You can see if that works for you. All right. The 3D display types are going to be broken down into two main categories, right? Your stereoscopic and your autostereoscopic. The kind we just viewed in the video before is an autostereoscopic, meaning there was no extra things that you needed to use in order to get that 3D effect. And the stereoscopic ones are going to have to be the 3D glasses that you're wearing or those polarizing 3D glasses. So that's where the two branches kind of take you. And when you watch this next video, I want you guys to see if you can pay attention and actually kind of see the depth in the image. See if it looks 3D to you. See if you see any hazing on the colors or anything like that.
Wow. Nice.
Wow. see that depth? You see things coming out at you and things in the background, things in the foreground, things in the middle ground.
If you look at it without the glasses, you can see how it's two images, and that's what one image is going to your left eye, the other one's going to go to your right, and that's what's creating the effect.
You ever suck the honey out of
It's like reach out and touch.
Yeah. It really projects a lot to you.
Now, when people watch the video of this, they need to wear.
You need to have the glasses. Yeah. I'm gonna pause this here, and I want to take you to the end, and they show the camera that was used to make this video, and I want you guys to look at it. It's also in 3D. But take a look at the camera setup, and then we'll talk about. So this is how he actually did it. He used two cameras, and he was actually taking a macro type image of it, so he needed to get close up. And in order to get close up, he had to keep the focal distance between the two lenses really close. So that's why he's using the mirror and prism to get these real super close-ups, but still two separate images of the flowers for this video. So that takes us to back to
I want to throw something in there too. If you've all gone to like a movie or a 3D movie, and after a while we start to get headaches,
Yeah.
that's because we're getting the two images and our brain's like, it's confused, doesn't know what's going on. So at first, we'll see in 3D. But that trick of getting two images and converting them into one, after a while it starts to give us a headache.
So basically, 3D movies are bad for your health.
Not bad for your health. It's just tricking your brain, and your brain's smart enough to know that something's going on,
Oh, okay.
and that's where it goes. Another type of 3D display is in consumer products is the auto stereoscopic one, which this is a Nintendo 3DS. I don't know if anybody's seen this, but what this does is it's got the same thing. It's got two camera lenses on it, and what it does is, I'm going to pass this around so you can see how it is. You've got to view it at the proper angle, straight on, about 12 inches away from your face, and that's the only way you're going to see the 3D image. If you crank on it to the side and look, and you go the other side and look, and nothing looks like it, there's a reason for that. So go ahead and pass that around and take a look at it. No, not with it. Just look at it. It's automatic 3D, so there's nothing needed. And what it is it breaks up the pixels in the screen into columns like this, the red and the white, right? And then what it does is it brings in a parallax border, this thing right in front of it. So it's got another LCD that's off when it's in 2D mode. And then when you go to 3D mode, what it does is it breaks up the pixels, cuts them in half. So your left eye is going to see the white, the right eye is going to see the red, and then it turns on a parallax border in front of it, which is black. And what it does is it prevents one eye from seeing, the wrong eye from seeing the red so that your right eye can see it, and the left eye from seeing the white so your right eye can see it, or vice versa, how you do it. So pass that around, and you just hold them out like this, and you kind of just play with it till you get the right angle, till you see one color in one eye, the other color in the other eye. And that's basically the whole primer behind how these things are done. You either do it automatically with it's something in the screen with a parallax border, or you do it with glasses and just sending one signal to one eye, another signal to the other eye.
Is that similar to the pictures that you can stare at and find them in 3D?
The Magic Eye stuff.
Yeah.
I don't know how that works
Okay, 'cause
exactly.
It always felt similar.
Yeah.
Looking at the,
Yeah, I'd have to think about that.
Alright.
I'll look into that.
Cool.
So there's the display types.
Are these melted Swiss ties?
No. So the benefits of 3D images.
So I mean, it's nice to have 3D, but what is it good for? So let's say my favorite one is camouflage. Like, have you guys ever seen like a chameleon, like a tree? You can see he's like that he's there, but you can't really. You see, like, you know something's wrong. So what that is that it's each of our eyes, and we see depth within like the chameleon and the tree. We know one's closer than the other, and that creates that outline that we can distinguish. And that's useful for, say, when we evolve, for hunting prey, things like that. For surface metal perception, when it comes to like gems, the light reflects in like a certain way, and because we have binocular vision, we can see like the sparkle or the effects of like a gem as with light.
Yeah. So summing up, just like what Warren was talking about earlier, is we're humans and we see in 3D. We have depth perception. So when we look at a 2D image, it's hard for us to get a lot of valuable information out of that. And if you can take an image and bring it into 3D, then you can get a lot more stuff about it: the surface, the texture, how big it is, volume, things like that. So that's the benefit. We're humans, we see in 3D, and so when we look at 2D images, we're kind of stepping down. And to understand how this works, the basics of depth perception, right? Along the line E are the two eyeballs. Z is the distance to the object. This is the actual object we're looking at D. And then behind that is the focal point, right? And that's how our eyes normally see things and translate it into 3D depth, right? So that's how we get the near field, the middle field, and the back of field. And that calculation right there, the perceived depth, PD, corresponds to all these things, and that is the basis behind all converting images, videos, either still or moving pictures, into 3D images. They're all variations of that one formula there. Even from the open source graphics libraries that you can download to process your own videos into 3D, and the high-end stuff that Sony's doing with the IMAX and the RealD 3D and all that stuff.
So let's do it for a second.
Mhm.
These variables, if we change them, they're going to alter the depth that we see. So with Z, if we increase it, the depth increases as well. With D, if those two dots separate, we increase the depth. And with E, if that one decreases, the depth is going to increase.
Good. Next slide. All right, and so this is the way I naively thought that I could take a photo that I'd already taken and just process it and turn it into a 3D image. Well, come to find out that that's wrong, but then later on that'll be true. So you need to actually have two separate images to process into one image to turn it into a 3D image. And these are the basic setups. You can either have the images parallel, taking one here, moving over 3 inches, taking another, or you can have them towed in. And that's where you stand at one pivot point, you take an image, and you turn and you take the other image, right? And you take those two images and you process it in a computer into the one 3D image that we saw. And then this is where the math gets involved. Now that we have our two images, what we do is we're going to use a computer to do it. And it's going to do a whole bunch of vector calculus for us, right? It's going to go through pixel by pixel in our image, and it's going to process it based on the positions we give it from that previous equation we saw. And the most common one for the do-it-yourselfer, there's an OpenGL, which stands for Graphics Library, written in Python, that you can use to process your own images into 3D. And if you get that and you break it down, it's just line by line standard vector calculus stuff. It says it's basically an equation where the viewer information is given, and then they calculate based on the information you give them how far out and at what angle that pixel needs to be in relation to its corresponding pixel, so that way you can generate that depth. And this slide right here shows the considerations. This is actually the variables in the calculation that the graphics library, the computer processes, use. It sets up the far depth of field, the middle depth of field, and the near depth of field variables in any picture you process.
So I mean, you could think of this as like, instead of the TV, the TV is going to be W. And then whenever they want something to appear closer, like in the video, like the flowers, it's going to go towards the near by changing those variables. And the same thing for something further away.
Okay, so what are the applications? Anytime that you take humans that look at 3D images and you can give them a 3D image that they can better understand, it's going to enhance their ability to work with the material. A common one that they're trying to do right now is airport security x-ray machines. They're trying to get to where they can process something through and the image that comes up on the viewer's screen is actually in 3D. That way they can kind of get a better idea of what's a laptop versus toothpaste versus what's going to be a dangerous object. There's obviously the entertainment applications, which are big, the movies, the video games, everything like that. The medical applications, letting a doctor actually visualize a person's spine so that they can pinpoint if it's pinched, if a nerve's pinched, if they can see the bone and see how it's broke in 3D, then that's going to give them a better understanding of how to fix that problem. Engineering and radar viewing. Radar viewing so that pilots, the flight controllers can actually view where the planes are in 3D, because right now all they look at is a 2D scope of the image out there, and they've got to read the altitudes on that thing in order to allow the planes to miss each other. So if you gave them a 3D image, they could probably stack the planes better for landing. The last application is a military application, and these are PVN 14s. These are military night vision goggles, and what this does is just the opposite of what we're talking about, right? This takes one image viewed through this lens and then splits it up into two eyes, and when you put these on, it removes all your depth perception because you no longer have the ability to see in 3D. And in the Air Force, when we would train with these things, they would put us in a dark room, we would all put them on, and then they would turn them on, and somebody would get up, and they would walk to the speaker's voice, and they would get to where they swear they could touch that person, and they'd reach out, and the person wasn't there. And why was that? Because your depth perception was removed, and you can't see. And that's one way that 3D vision would actually help this. So I don't know if anybody wants to try it. All right, you can come up.
Still looking to
Wait, no,
Wait.
well, I don't believe.
When I was in military, this was classified, this equipment.
All right, put these on one. Yeah, hold them out.
That was,
Were you in the US?
Okay, now just holding them with one hand. Can you see these glasses in front of you?
Yes.
Okay, reach out and try and grab them.
Uh,
You see how he had to take that extra grasp out?
Yeah.
Right there, does it look like you're actually touching them?
They turned off.
They turned off?
Yeah.
Let's see. Batteries might be dead. But anyways, there we go. Don't look at that light. It actually might be turning it off because of that. But see if you can just reach out and grab them. See, I don't know if you can see it. Here, turn this way for us, Juan. Try and grab them. It's funny. So anyways, that's our presentation.